To take you through the process of carbohydrate digestion and absorption, I'm going to give you an example of a meal that I actually consumed today for breakfast and talk about how the carbohydrates in that meal will be broken down and absorbed. So for breakfast, I had some whole wheat toast with peanut butter and honey, and then I had some yogurt, plain yogurt that added some honey and some strawberries and blueberries and some nuts to that meal. So as you can hopefully remember, thinking about all of those foods I consumed that I just described, the different types of carbohydrates that would be in those foods. So let's just focus on the carbohydrates in the foods. So thinking about the bread having starch, it's in whole grain, so it's going to have some fiber as well. And then I had yogurt, which is going to have some lactose. And I had fruit and honey, which we're going to see that we're going to have fructose in there. We would also have some glucose in there. And I actually probably would have some added sugar as well in the bread. So there would be sucrose in there. So you can see that in my breakfast, I really had every type of carbohydrate that we've talked about in this class. So let's take that meal through digestion and absorption. So in thinking about digestion and absorption of carbohydrates, you need to think about the GI tract and those accessory organs. So thinking about the GI tract being the mouth, the esophagus, the stomach, small intestine, large intestine, and thinking about our accessory organs, including the pancreas, gallbladder, and liver. And in this case, you're going to really see, your salivary glands. So in this case, you're going to see the carbohydrates, only some of those accessory organs are really key players in digestion and absorption of carbohydrates. So this is the book's figure looking at carbohydrate digestion and absorption and going through this process. I'm going to give you the simplified or abbreviated summary for the things you really need to know for this class. So we think about in the mouth, what's happening here? Well, I'm thinking about my bread that I had that starch. Remember, the starch are linkages of glucose molecules, and it's a polysaccharide. So what happens is chewing is going to help break up the bread, of course, but then we also have saliva being released, and in that saliva are enzymes. Those enzymes are actually breaking those bonds between the large chain of glucose molecules, and it can actually break it down all the way to the disaccharide maltose, which is just two glucose molecules together. If I kept chewing and chewing and chewing that bread, it would all actually turn to maltose. And you can actually experiment with this. So you can take a cracker or you can take a piece of bread and chew and chew and chew, and you might notice that if you just have the bread alone or the cracker alone, that it gets sweeter over time because maltose is being produced, and maltose is actually sweeter than a starch. Second place, so now swallow that food, and again, remember I had different types of carbohydrates beyond just the bread, so I'm swallowing that food. In the stomach, really nothing is happening, so there's no action on digestion or absorption of any of the carbohydrates. We do have the turning that's going on. The hydrochloric acid is going to be released, and we're going to see that it's going to that the food particles are going to become more liquefied, and they're going to then get exported or spit out into the small intestine. The small intestine is really where the hub of the action of digestion and absorption occurs with carbohydrates. So 3 and 4 go hand in hand. Why they go hand in hand is because enzymes are being released by both the pancreas, which is an accessory organ, and the actual small intestine itself, which is part of the GI tract. So thinking about the different types of carbohydrates that I consumed in that meal. So think about the starch. So again, some of that starch has been broken down to maltose in the mouth. So some of it's going to be arriving in the small intestine as that disaccharide, but there's still going to be some chains of glucose molecules together that are longer than a disaccharide. So what will happen is enzymes that are coming from the pancreas are going to help break down those smaller, those linkages of glucoses into smaller polysaccharides, or maybe it's going to break them down into disaccharides. So in the case of starch, down to maltose. Now remember that in my meal, I also had some monosaccharides. So I had fructose, I had some glucose, I would have had sucrose and lactose. So monosaccharides would be just the glucose and fructose free, and then the disaccharides would be the lactose, and then also having sucrose. So what's going to happen to those disaccharides? Well, one thing that's important to know is that we have to have the carbohydrate has to be down in a monosaccharide form in order for it to be absorbed into the small intestinal cell and then get transported out to the blood and then goes to the liver. So essentially we have to get those down into a monosaccharide form. So how do we do that? We do that with enzymes. So essentially we're using small intestinal enzymes to break up a disaccharide into its monosaccharide forms. So for instance, my sucrose, there's an enzyme that's in the small intestinal wall that will break that sucrose down into free fructose and free glucose. And as far as the lactose, same thing. We have enzymes in the small intestinal wall. They'll break that disaccharide down into glucose and galactose. So now they're monosaccharides that can be absorbed across the small intestinal cell and out into the blood that then transports them to the liver. So again, enzymes from the pancreas, small intestine, are breaking down long chains of polysaccharides into smaller chains, into disaccharides, and then we have, when they're disaccharides, we have special enzymes in the small intestine that actually break those down into monosaccharides for us to absorb them. Well, in my meal, I also had whole grain bread. So that whole grain bread is going to have fiber in it because it contains all the whole kernel. And so what's going to happen to that fiber? Well, if you remember from other videos, you can't break that fiber down. We don't have the right enzymes to break those bonds. So it remains undigested in the small intestine, travels through till it reaches the large intestine. Then we have bacteria there that can actually do something with that fiber. It can ferment it, and as it ferments it, it creates other compounds. So it creates short-chain fatty acids, and it can create some gas. And that really is a summary of digestion and absorption of carbohydrates. If you have further questions, don't hesitate to contact me or the TAs.